And in problem 3, your job is to solve this system of two equations. So we want to know what x and what y simultaneously satisfy both the equation negative 3x minus 4y equals 11 and negative 5x minus 3y is equal to 0. So what's the strategy that you would use to try and solve this system? We have two different strategies in our course for solving linear systems. Which one do you want to use in this problem? Meaning what? So elimination is a good choice for this system because in this example at least it makes some sense. If we had, so compare this to if I had a system that looked more like, I don't know, y equals 12 minus 3x and then x plus 2y equals 8 or something like that. In an example like this, we would probably be advised to use substitution instead of elimination because one of our variables has already been isolated. One of them has already been solved for, which allows you to take that expression, 12 minus 3x, and just stuff it into the second equation where we see the y. Right? So that example is already kind of set up for us to do substitution, to get rid of one of the variables, and then solve this for x. But in the example that we're working on, neither one of those variables has already been solved for us in one of the equations. They're both all on the left-hand side. So elimination is probably the way to go in this problem. Substitution would make you work a little bit harder, I think. Yeah, that's the other thing. Substitution would introduce more fractions, where if you follow elimination, chances are you can do everything with mostly whole numbers until the last possible instant, possibly. So what does the elimination method look like for this example? We want to focus on one of these two variables, either the x's or the y's, and put it in the crosshairs, because we want to eliminate, either eliminate the x's or eliminate the y's. Which did you choose to try and target, to get rid of?
Let's do the y's.
Let's try the y's. I would think that the y's are a slightly more natural choice for this, because the least common multiple of their coefficients, 4 and 3, is 12. Which is smaller than the least common multiple of the coefficients of the x, which is 15. Ultimately, it doesn't matter, but my instinct would be to go after the y's here. So how does that happen? We need to make it so that the coefficients of y are equal and opposite in these two equations. How do we achieve that? I need to do something to each of these equations. It doesn't have to be the same thing to both equations, but I have to do something to each of these equations to make it such that I end up with a certain number of y's, which in the two equations is equal and opposite. So if I have 10 y's up here, I need to have negative 10 y's down there. If I have 25 y's up top, I need to have negative 25 y's on the bottom. What's a good number for us to shoot for of y's? 12 is a good number to shoot for, because again, it's a common multiple of 4 and 3. How can I get 12 y's out of this first equation? What do I have to do to that first equation to create 12y? Multiply it by 3. If I multiply that first equation by 3, I'll have minus 9x minus 12y equals 33. How about the second equation? Multiply it by 4. I'll get negative 20x minus 12y equals 0. So now I've succeeded in making the coefficients of y equal. But what I wanted to do is I wanted to make them equal and opposite, just to make our lives easier so that we can add these two equations together. So I want to flip the sign on this 12y in one of the equations from minus to plus. How can I do that?
From a minus to a plus?
Yeah, let's say I want to make this minus here into a plus instead. Yeah, instead of multiplying this one by 4, let's pretend that we instead multiplied it by negative 4. That's going to have the effect of turning this negative 20 into a positive 20, this negative 12 into a positive 12, and this positive 0 into a negative 0. Well, that has no effect at all. Right? Again, I want equal and opposite just so that my next step is simply to add down these columns. If I then add down these columns, I'm going to end up with, on the right-hand side of my equation, 33. My y's, negative 12y plus 12y, what's going to happen there? Yeah, we're going to end up with 0y, which is no term at all. And then 20x, negative 9x plus 20x is going to give us 11x. And now we've eliminated the y, and we can solve that equation for x. How do we solve that equation for x? Yeah, just divide it by 11 and get 3. The great thing about a multiple choice question is that oftentimes this by itself is enough information to know what the right choice is. There's only one of these options that has x equals 3. But if this were an open response question, we would also have to know how to find that y. So how could I have found that value for y at this point? Yep. Just take that value for x and plug it back into which of the original equations? Yeah, ultimately it doesn't matter, but let's just pick one of them. Pick the bottom, say. So in place of x, we'll have 3, negative 5x, minus 3y equals 0. And then we just have to solve this linear equation to get the value of y. And there, most people are on autopilot. We're just using SADMEP, adding and subtracting until we can't do that anymore, and then dividing until we can't do that anymore. Negative 3, so y equals negative 5.